welcome to this video of Labview. So we are going to go back and just continue where we left off. So last time, we were doing some Labview program with a slider that you're able to control a time varying input into some transfer function. Okay, just like so. Unfortunately, there was some lag with this waveform chart. This waveform chart here is lagging behind this transfer function. Okay, and actually sometimes, depending on the settings you play with, there will be some error. Okay, so if I stop, then maybe let's do it this way. I'll close it. Okay, just to see whether I can replicate the error. I'll close it. I'll stop. I'll run. And then I'll make this thing go twirling up and down a little bit. I'll stop and I'll play again. Okay. So, I mean, depending on it doesn't seem to be able to replicate the error very well. But this waveform chart will not start from 0. Okay, the waveform chart will not start from 0. It will start from wherever the data last left off. No need that. Sometimes this form will give you some error. Some error which I don't really understand how it's coming about, but it'll say that something's missing or yeah, I can't remember what exactly it is, but there may be some errors with this waveform chart. Okay, and the most important thing is that it lags. Okay, it lags, and sometimes when you deal with systems, you cannot afford to have that lag. Right? You cannot afford to have that lag. So how do we avoid this lag altogether? So I'm gonna stop. I want to introduce something to you called local variables. Okay, so this wire, I'm going to delete this wire branch. I'm not going to use this model hierarchy to access the output Y signal. So I am going to delete this output. I'll leave accessor 1 as it is, and I'm going to reduce the decimation to 0. So it will take 1 out of 0 samples, or I think not 1 out of 0. It will not take any samples at all. Okay, so that because we are not collecting data using this method. Okay, let's see. Okay, 17 minutes, should be able to finish. Okay, so what's the other method? Okay, very easy. It's called local variables. What it does is that what local variables will do is that it will read the real-time data of this wire over here. Okay, but unfortunately we cannot, as we found out before, we cannot just wire things out of this control loop like that. It will not give us the correct result as we saw before. So what do we then do? Okay, so very simple. Go to data communication. Okay, this is very important. Data communication. Go to this thing called local variable. Global variable also works, I think, but we'll start with local variable. What does local variable do? Again, it will just read any data that you want, and it will display it out in real time. So for example, you want to read this output of the transfer function here. Okay, what do? Okay, so you click on it. Oops. You right click. Let's see. You select this local variable. It should be change to read. Okay, change to read. So it will read off some some variable anywhere in this block diagram. Doesn't have to be in the control loop, or it can be in a control loop or outside a control loop, or I mean simulation loop. It can be in or out of the simulation loop in any while loop or whatever it is. So once you change to read, of course you can change it back to write, and that one I can show you how to use it later. But we'll use this local variable in read mode. So what does this mean? It will read off one of these variables here, some time varying value. So if you click this change to read, you have a selection of things you can start to look. Okay, you can start to look from. So what can you use? Okay, alright. So so this you can put it. There's an input. There's an output. Where's the input and output? Okay. The input and output are. It looks like there are these waveform charts over here. So input, output, and transfer function 2. Let's change this. Let's just call it sine input so we know what this is. Okay. Sine output. Alright. And transfer function 2. So if we change it, you can see there's a sine input, there's a sine output, there's a stop button, and there's a waveform chart, which is this one. This will be our outside control loop chart. Okay, so basically I'm able to read the waveform charts inside these transfer functions. So for example, let's just do this transfer function 2. This will be a waveform chart. This will be a waveform chart. So can delete this wire. What I can do, very simple, I can just wire this up here, and okay, I think touch your heart, there should not be a lag. Where's the build array contains unwired or back terminal? So yeah, this is the one. Okay, so I'll delete this. I'll show you the lag free way of getting this process variable in real time. So if you take a look now, this is the outside loop control loop chart. Okay, so if everything works out correctly, the transfer function 2 graph and this outside loop control graph should be exactly the same. So let's press play. So you see, now they are completely the same using this local variable technique. Of course, the timing and whatever is not going to be exactly the same, but you know, it sort of works. Okay, there is no more lag over here. Okay, so you can see it's very responsive now using this local variable technique. Okay, but is there a nicer way to do this? If let's say I want to just pass the value out instead of passing this transfer function thing out. Okay, no problem. So what you want to do now, I think you can use this local variable to start reading something. So let's say I have this. Okay, remember, you can just put this local variable in the chart here, and remember I said there was a write and a read function. So this is the write function. This is the right way, where you are writing some piece of data to this local variable. Okay, so let's see. It doesn't really write or anything. Okay, so maybe that's not the way. Let's use a numeric indicator. Okay, oops. Numeric indicator. Where's the indicator? Okay, maybe you have to do it in the front panel. Let's do this numeric indicator. Maybe I can do some vertical progress bar or something like that. I'll bring it in here. Okay, so that should about do it. Okay, now this numeric indicator is piped to this slide thing over here. If you press play, this slide will go up and down based on, of course, this graph here. You can change the scale if you want, but now you should be able to pipe this data on this slide to this this local variable here. Okay, I mean, yeah, you should be able to pipe data from this slide to this local variable here, because all of this needs to be in some place. Okay, so all of this needs to be all this data needs to be piped to some place, for example the slide. So I'll need to change, and I'll put the slide here, put it like a slide over here. So that will be a sort of an indicator. So let's see. Hopefully this thing actually, or maybe we can change it to some numerical indicator. So let's replace it with, okay, replace numeric. We just do a numeric indicator. Nothing too different here. Okay, and let's do a build array. Build array. I'll wire this up, and I'll wire this in here. Okay, let's see whether this works. Okay, in theory, I think it should. Okay, so it does work. You can see this. I mean, okay, yeah. It does work. It's showing the correct amplitude at the correct time. Oh, okay. I think this numeric is an integer value. I should make it into a double. Okay, let's replace. I think that's why it's blue. It should be a double. Let's put a gauge instead. And the gauge will... Okay, let's see whether we can... data operation. Okay. Yeah, it seems to be taking it integer values now, so that's not the best. Okay. I'm gonna put this aside. I'll put this aside. Let's try again. Maybe I'll have a numeric indicator as some double, or some meter, or what else? Okay, I'll have some horizontal progress bar. No, I don't want that. Okay, never mind. Let me fast forward this bit. Alright, so okay, so basically I just deleted everything of those local variable thing, and let's start again. Okay, so I think the way to do it is to right click this wire and create an indicator. Okay, this indicator will be over here. Okay, it will be called output YT. Alright, so where will you have this indicator? This indicator will be over here. Okay, so this will be some Y output of transfer function in control loop. Okay, YT. Okay, so now you should be able to since it's piped to some it's piped to some variable here, some indicator. You pipe it to some indicator here. Now you should be able to use a local variable to read this thing. So you'll go local variable, you'll click here, you'll put it outside, of course, outside of the control loop. Then let's change to read. And what do we want to read? We want to read this output of transfer function in control loop. Alright, so that's good. Now we have this, we can of course use the array building tool and a waveform graphical tool, which you can insert in the front panel, a waveform chart. You just put it here. So this is a chart outside control loop. Okay, chart outside control loop, and now of course just wire this in, no problem. Alright, so no problem, we'll have this, and look, yeah, now the thing is working properly. You can see both of them. Okay, both of them are going like at the same time, though of course the x-axis is not time anymore. It's like this is a varying sample of something that goes with time. Okay, this is the YT sample that goes with time. However, this bottom axis is not time, it's like a sample number or something of that sort. But the thing is that you can see that the lag is completely gone, and that is very important. Okay, the lag's completely gone. and you can see the real-time value of YT actually here. And of course, if you want to have your indicator, if you want to have an indicator, so you can create indicator from this. Okay, output of transfer function, output of transfer function outside control loop YT, and that's totally doable as well. So this is the one outside the control loop, and if you check these two numbers, they will be pretty much the same. Okay, you can see they're changing at almost a real-time speed. Okay, they are changing almost at the real-time speed, which is absolutely what we want at the end of the day. So if we shift this output down to 0, then it will go into the negative because there will be some overshoot. But after that, it will come back to 0. So that there's some overshoot, and it will just settle down after a while. Of course, these graphs are making me a bit dizzy. So what we can do is, of course, change the scale to go from maybe minus 15 to 15. Okay, so we go to the, okay, again, go to properties. Okay, and go to scales. On your scales tab, go to amplitude, and you can just put minus 15 to 15. So it'll give you less of a headache. Likewise for this this one, we can do it with amplitude. We'll scale it to minus 15 and 15. Then we can start playing with the slider again. Okay, so now the signal's at 0, we can shoot it up to 10, and then you'll see both graphs shooting it up to 10. Of course, this is a much more zoomed in version compared to this, and that one you can just alter the scales accordingly. But you can see the latency is just not there anymore. And then now you push it all the way down. Okay, push it all the way down to 0, and then it will shoot past below 0, and you see they're responding at the same time. Okay, so I believe this I've emphasized this a lot of times. It's gotten the point across that once you use this indicator, once you right click here and then you can click create indicator, you should be able to read this value using some sort of output. Okay, some sort of local variable. Okay, no problem. All right, so what if we want to now get rid of this, how do you say, you want to get rid of this step signal. Maybe we want to try using this local variable thing to input the step signal into this transfer function. Okay, what do we do? Okay, so what I'm going to do is this. I'm going to have a what do you call that? Go into control and simulation, go to simulation. I'm going to have a summation of two signals. Okay, go to signal arithmetic and go to summation. Okay, then of course you click this, you can change this to a cancel, a plus, or anything else. So this thing will add up two signals. So again, click on this summation, which you will find under your control and simulation palette. Under what do you call that? Signal arithmetic. You'll have a gain, summation, and multiplication. Summation will be in the middle. And of course, again, if you want to change any of these things, these terminals, it was originally negative. If you want to change it to plus, just click until this thing, left click until this part has a plus. Okay, so I'm going to wire this in to and wire this out here. Okay, so it will take a step signal here and another signal to put it into this transfer function. Okay, so what am I going to do? Well, we'll call this, I'm going to put another input over here. So let me start by differentiating these two inputs, or rather, okay, let me put an input in first. Maybe I'll use some sort of a knob or dial. Okay, I'll call this a outside sim loop input. All right, outside sim loop input, which is not really outside the sim loop now, but we'll drag it outside the sim loop. Okay, and then we'll use a local variable or some sort of indicator, right? Oh yeah, we can just use a local variable, I think, straight away. We can go to data communication, go to local variable, and we can select a read mode. Okay, same thing that we are doing here, except we are doing this local variable inside the sim loop. Oh, okay, we're already at 20 minutes, but okay, let me do this part and we'll finish up. This local variable will read outside the sim loop this input. Okay, notice you don't have to actually wire this to anything. So this is the output. Oh, sorry. This is the outside sim loop input. So you just select the correct one, outside sim loop input. Okay, change the local variable, make sure it's in read mode. Then you can do this. So you can drag it around and put it on top here. So now we have two ways of putting in input. One is through this access model hierarchy. One is with the use of local variables. So I'm going to press play. And I'm going to turn the dial up. Okay, and look at this. It's now going up to 10 or something. And then of course we can use the access model hierarchy method, and then I'll just push it up to 10 anyway. So it should pass the maximum reading of this graph. And I can shift it down again. Okay. Then I can shift this up a little bit. Okay, so yeah, whatever it is, basically what I'm showing you is that with the use of local variables, you can take a signal outside this control and simulation loop and pipe it in. You can pipe it in. Of course, you don't need the summation here. I'm just showing you so you can see there are two methods. One's the access model hierarchy method. One is the sim loop. I mean the local variable method. And of course, you can read the outputs again using local variables, which is much more efficient than, let's say, some. Oh my goodness, why is it like that? Yeah, we can use this local variable to read all of these outputs of the transfer function in real time. So we actually don't need all of these things here. We know that this and this is actually pretty much the same. Okay, if you want this specific graph, the information for this specific graph to be piped outside, you can do that as well. I just showed you how to do it. Okay, but I mean, otherwise it's a very simple thing to do. Okay, if we don't want to use this method, we can use even a local variable to let's put this transfer function to outside. Let's unwire this, and we'll just have some indicator. Okay, this waveform chart here will be over here, but the way I'll be getting the chart outside this loop is with the use of another variable. Okay, we can use another okay, the last variable, just for the sake of showing the example. Local variable, we put it here. We'll change to read, and we'll want to read the waveform chart. Okay, the waveform chart will go into this transfer function thingy, and the chart outside the control loop will be, I'll just like leave it out. Okay, we'll save ourselves some space. Okay, and we should be able to start to again play around with the values if you want to. And you can see this time is actually changing with time is changing with this excuse me. Yeah, time is changing with this y value. Okay, so you can see the y values are being read, and now we have one that's changing with time. Again, very simply we can just pipe all this data outside using this local variables. So that's a very simple way of getting things done and circumventing that wiring problem that we were having earlier. Alright, so that's all I have for you. Okay, so this shows you can actually change your transfer function, pipe it in and out using local variables. Very simple. Okay, thanks for watching. Bye bye. Okay, I'll stop right